So the first definition in payloads is basic empty mass or basic empty weight, also called tail weight. It is provided by the manufacturer of aircraft, example Airbus, Boeing, Bombardier, etc. It includes the basic equipment in aircraft, the aircraft itself, oxygen apparatus, carbon dioxide cylinders, hydraulic fluids, hydraulic oils, electronic equipment, and a little unusable fuel. So it basically is the basic aircraft and has no fuel in it, no crew in it, and no passengers up till now. The next stage, we just add crew, the baggage of crew, catering and portable service equipment, and portable water lavatory chemicals to the basic empty mass. Then it becomes dry operating mass. So the second definition in the topic is dry operating mass, also called dry operating weight. It is also called APS, aircraft prepared for service. It means the aircraft is ready to serve the passengers. The third definition is traffic load. Basically there are three kind of loads. The first is traffic load. It means the passenger, the baggage of passengers, and non revenue generating load. So basically what happens is when passenger pay to the airlines for travel, they are called revenue generating load. So because they are creating revenue for the airlines. And there is one thing called non revenue generating load. For example, if I work for an airline and I get to travel sometime for free, so I will be a part of traffic, but I won't be helping in creating any revenue for airlines, so I will be non revenue generating load. And second is fuel on board. Basically all the fuel included in flight except taxi and start fuel, we get fuel on board. So basically it is burn off fuel or flight fuel or trip fuel, whatever you call it, and reserve, alternate, holding fuel, and contingency. All these together is called fuel on board. The third part in the traffic load is useful load. So basically when we add the traffic, it means the passenger and their baggage, and the usable fuel, we get useful load. So useful load is payload plus fuel on board. The next definition is zero fuel mass. The moment when boarding is done but aircraft is not refueled is called zero fuel mass. So no fuel is added but the traffic or the passengers have boarded the plane. Second is maximum zero fuel mass or maximum zero fuel weight. As the name suggests, it is the maximum permissible mass of aircraft with no usable fuel. So basically dry operating weight has basic empty mass and crew plus lavatory chemicals, water, etc. So we can consider dry operating weight to be constant. So when we maximize the payload or passengers and baggage, we get maximum zero fuel mass. The takeoff mass, the mass of aircraft at the start of takeoff run is called takeoff mass. So this is the basic equation. Also we will need this equation while solving the numericals. So takeoff mass is equals to dry operating weight plus payload plus fuel on board. So we get takeoff mass. Maximum takeoff mass, the maximum permissible mass while taking off, is called maximum takeoff mass. There is one more takeoff mass, it is called performance limited takeoff mass. So when the conditions of surrounding lets us to carry little weight than what we can carry in idle conditions is called performance limited mass. For example, high temperature, wet runway, high density altitude, the performance of aircraft gets a little less, so we cannot carry as much as we can in idle situations. So this is called performance limited takeoff mass. So now we will discuss maximum structural landing mass or maximum landing weight, right? It is maximum permissible mass upon landing. It means if we increase the landing mass beyond this, beyond maximum landing weight, the structure of aircraft may get destroyed. It will create minor cracks or create stress to the frame. So it is not suggested to land an aircraft with any weight above maximum landing weight, and this is the reason fuel dumping and fuel jettisoning is done in some cases. Maximum ramp mass or maximum structural taxi mass. It is the weight permissible for ground maneuvers. Basically, it is maximum takeoff mass, and we add start and taxi fuel to it. So after we are through with our taxi and lineup, we always get our maximum takeoff mass, which we cannot exceed. Just quick revision of what we have done up till now. So initially we had basic empty mass, which was just the basic aircraft. We added crew, the baggage of crew, water, PSC and lavatory chemicals. We get dry operating mass. So from dry operating mass, we can get takeoff mass in three different steps. Either we do the boarding first, either we do the boarding first to get zero fuel mass, and then refueling is done, then we get our takeoff mass. The second option is we do the refueling first, to get operating mass, and then boarding is done to get takeoff mass. And third condition is we do boarding and refueling simultaneously, which was payload and fuel on board simultaneously, and this together is called useful load. And we again get our takeoff mass. So in takeoff mass, if we add start and taxi fuel to it, we get taxi mass. And if we subtract trip fuel, because it includes our trip fuel also, if we subtract trip fuel after the flight, we get our landing mass. So if we have our landing mass and we add the trip fuel to it, we will get the takeoff mass. Please remember this, we will need this in solving numericals. So now discussing the numerical point of view, the basic equation is takeoff mass is equals to dry operating weight plus fuel on board plus payload. So the dry operating weight will always be given in the questions. And the first thing you will have to calculate is takeoff mass. And there are three methods to calculate takeoff mass. First is it will always be given in the question, maximum takeoff mass or maximum takeoff weight. As told earlier, if we add trip fuel in maximum landing mass, we get our takeoff weight. So this is the second method of calculating takeoff weight. And third is if we add trip fuel, alternate, reserve and contingency fuel to maximum zero fuel mass, we will again get our takeoff mass. Right? So these are all nothing but takeoff mass, and please do remember, do not consider start and taxi fuel in any of these cases. Do not add taxi and start fuel in any of these three methods. So again, back to our basic equation, takeoff mass is equals to dry operating weight plus fuel on board plus payloads. So I have told you how to calculate takeoff mass. Now dry operating weight will be given to you. Now we will see the method of calculating payloads. How to calculate payload? So while calculating payload, you have to consider minimum of the three of these method of calculating takeoff mass. So first you write down what was maximum takeoff mass given in the question, and then calculate the second quantity, and then calculate the third quantity. These all will be takeoff masses, right? And consider the minimum of these three. So the minimum of these will be considered for calculating the maximum payload or the payload. So this was the case 1 where takeoff weight will be calculated from the given data, dry operating weight will be given, fuel on board will be again calculated from the data, and payload will be calculated. You will need to find the payload in these kind of questions. The case 2 is you will again calculate takeoff mass from the data, dry operating weight will be given, fuel on board will also be calculated from given data, and payload will be calculated as the answer. And then the second part will say you have to calculate extra fuel with same payload. Now what will you do is you have already calculated the payload. Now consider the minimum of first two takeoff masses. Let me show you again. These two. So from these two quantities you will consider the minimum quantity and calculate the extra fuel with this equation. And case 3 is you will need to calculate the useful load which is payload plus fuel on board. It is easy, you will do it within seconds. So basically these are the three cases of numericals related to payload. So this is the first example of case 1 where we will be calculating maximum payload using given data, and the given data is maximum takeoff mass which is 45,000 kilograms, aircraft prepared for service or dry operating weight which is 22,000 kilograms, maximum landing mass is 35,000 kilograms, maximum zero fuel mass is 33,000 kilograms, flight time is 3 hours 30 minutes or 3.5 hours, fuel consumption rate is 1500 kgs per hour. It means for every hour the plane engines will be consuming 1500 kilograms of fuel, and the reserve is for 45 minutes. So now let us start with the question and solution. So let us first simplify and calculate the fuel on board. With that, we will start with trip fuel. So the flight time is 3.5 hours. If we multiply 3.5 hours with the fuel consumption, we will get the total fuel for the flight. It will be trip fuel or burn of fuel. So 3.5 into 1500, it becomes 5250 kilograms. And reserve for 45 minutes, 1500, which is our fuel consumption rate, into 0.75. So 45 minutes into hours is 0.75, 1125 kilograms. So total fuel on board becomes 5250 plus 1125 6375 is our fuel on board. Please remember this. So let us start by calculating the different takeoff mass. First is maximum takeoff mass, which is given 45,000 kilogram. The second quantity is maximum landing mass plus trip fuel. It is 35,000 kilogram, and the trip fuel is 5250. It becomes 40250 kilogram, the second quantity. And the third quantity is maximum zero fuel mass plus trip fuel plus alternate plus reserve. So we don't have alternate. I will erase this. Trip fuel plus reserve. It becomes 33,000 kilograms plus 5250 plus 1125. We get 39375. 39375 kilogram. And now we will compare and consider the minimum of these three. So the minimum quantity is this. We will consider it as takeoff mass and put it in our equation, which is takeoff mass is equals to dry operating weight plus payload plus fuel on board. The takeoff mass is 39375 is equals to 22,000 plus payload we have to calculate, and fuel on board is 6375. So payload comes out to be 11,000 kilograms. So our correct option will be 11,000. So this is the example of case 2 where we have to calculate the extra fuel that can be carried with same payload, and the first part we have already done how to calculate payload. So let us start with the given data. We have given regulated takeoff mass, which is also maximum takeoff weight or mass. Maximum zero fuel mass is 39.1 tons. Maximum landing weight is 43.25 tons. Trip fuel is 5.2 tons. Reserve is 1 ton. And dry operating weight is 27.5 tons. So let us solve for fuel on board first. Fuel on board is trip fuel plus reserve, that is 5.2 tons. So we have to calculate the three takeoff mass first. First one is maximum takeoff weight, which is already given is 50 tons. Second is maximum landing weight plus trip fuel, it is 43.25 plus 4.2, it becomes 47.45. And the third category is maximum zero fuel mass plus trip fuel plus reserve, it becomes 39.1 plus 4.2 plus 1 ton, becomes 44.3 tons. So now since we are calculating payload, we will take the minimum of these three, which is 44.3, this one, and put it in our basic equation. Takeoff weight is equals to dry operating weight plus fuel on board plus payload. We have to calculate payload. Takeoff weight was 44.3 is equals to dry operating weight was 27.5. Fuel on board was 5.2 tons. 5.2 tons plus payload. So payload comes out to be 11.6. Now with same payload, we have to calculate extra fuel that can be carried. So we are now calculating extra fuel. So please note that while calculating extra fuel, we will just have to consider the minimum of first two. And why not maximum zero fuel mass? Because In this case, we don't have any scope to carry extra fuel because we already have maximized the payload, and the space left is just enough to carry fuel for the given flight, and we don't have any space to carry extra fuel. So that's why in questions like where we have to calculate extra fuel, we just have to consider the minimum of first two categories, that's maximum takeoff weight or maximum landing weight plus trip fuel. So now we have this as our minimum, and we will calculate extra fuel with this 47.45 takeoff weight. So now again the basic equation, takeoff weight is equals to dry operating weight plus payload plus fuel on board. Our takeoff weight was 47.45 is equals to dry operating weight was 27.5. Payload we have calculated as 11.6 plus fuel on board. So fuel on board is 8.35. Now this is the complete fuel on board that we can carry, but we already have how much fuel on board? 5.2. We have this much fuel left, so how much we can carry extra is 8.35 minus 5.2. So this is our complete capacity, how much fuel we can carry, and this is how much we are already carrying. So what is the scope of extra fuel? The difference of this will be 3.15 tons. So we can carry 3.15 tons of fuel with the same payload, 11.6. So this is the answer for part 1, and this will be the answer for part 2. And this is the example of case 3, where we will have to calculate the useful load using the given data, and given data is takeoff mass. It is given 3,02,550 kilograms. Fuel on board is 1,21,450 kilograms, and this includes the alternate of 19,450 kilograms. So this is our alternate, and it is included in fuel on board. The dry operating weight is 1,61,450. So how do we calculate useful load? For this, let me go back in the video to the flow chart. So this is our flow chart. You can see here that if we add useful load in dry operating weight or dry operating mass, we get our takeoff mass. So let me write here, dry operating mass plus useful load is equals to takeoff mass. Right? So we have dry operating mass plus useful load is equals to takeoff mass, or we can also say that useful load is equals to takeoff mass minus dry operating weight. So now just putting the values, useful load is equals to takeoff mass is 302,550 kilograms minus dry operating weight is 161450 minus 161450 kilograms. So useful load comes out to be 141100 kilograms. So it is the easiest kind of numericals you can get in DGC exams.